Assalamualaikum and hi everyone. Today I'm going to present to you topic 5 functions and graph. Here we have the overview of subtopic 5.1 functions and 5.2 composite functions. So let's go through one by one. There are 4 types of relations. However, only 2 relations are considered as functions, which are one-to-one relation and many-to-one relation. To test whether a function is a one-to-one function or not, there are 2 methods that can be applied. The first one is horizontal line test. By using horizontal line test, if the line y equals to k cuts the graph at one point, it is a one-to-one function. The second one is algebraic method. By using algebraic method, if it can be shown that x1 equals to x2, fx is a one-to-one function. Otherwise, it is not. To find domain and range, we have 2 methods that can be used. It is a graphical method and algebraic method. For graphical method, we just need to remember that x-axis represents the domain of the function and y-axis represents the range of the function. For algebraic method, we just need to put y as subject matter for domain and x as subject matter for range. There are 6 types of functions in subtopic 5.1. The first one is a linear functions. The general form for linear function is fx equals to ax plus b, where a and b are constants. So this is the shape of the graph if a is positive and a is negative. The second one is quadratic functions. The general form for quadratic function is fx equals to ax squared plus bx plus c, where a, b, and c are constants. Note that we need to find maximum or minimum point by using completing the square if the function is in the form of y equals to ax squared plus bx plus c. Third, we have cubic functions. The general form for cubic functions is fx equals to ax cubed plus t, and the other one is fx equals to ax cubed plus bx squared plus cx plus d, where a, b, c, and d are constants. So this is the shape of the graph if a is positive and a is negative. The next one is absolute value. The general form for absolute value is fx equals to modulus ax plus b, where a and b are constants. So this is the graph for absolute value. Next, we have surd functions, where y equals to surd ax plus b is the general form. There are 4 types of the shape of the graph for the surd functions. So, we need to look at the sign of y and sign of x very carefully to determine the shape of the graph. Lastly, we have piecewise function. A piecewise function is a collection of several functions over a specified domain for each of them. So basically, a piecewise function is just a combination of the other functions.
Assalamualaikum and hi everyone. In this video, you are going to see part 5.2 composite function. The definition of this one is given to function f and g. The composite function denoted by f of g is defined as f of gx equal to f gx, and gx is an object of function f. This is also can be represented using an arrow diagram. This is an arrow diagram. So x is an object of function g and gx now is the object of function f. So we substitute gx into fx. But for g of x, we substitute fx into gx. And the conclusion is f of gx is equal to f gx, and gx is an object of function f. Second, g of fx equal to g fx, and fx is the function of g. And lastly, f of g x to the power of 2 equal to f gx to the power of 2, and gx to the power of 2 is the object of function f. That's all in this video. We see you in the next video. Thank you. Stay safe.
Assalamualaikum and hi everyone. Today I'm going to show the example question for topic 5.1 function. Let's go to the question 1. Graph the function and set its domain and range. As you can see, the question given is fx equals to negative x squared when x less than 0 and x plus 5 when x greater or equal than 0. If we can see, the question given is like piecewise equation. So we need to divide one by one to sketch the graph. So let's go to the first equation. Negative x squared when x less than 0. Because the equation is negative, so we will have the maximum points and the maximum points at 0, 0. As you can see, there are one condition is x must less than 0. So we must be looking the right side. For the second equation, x plus 5 when x greater or equal than 0. So for this question, we need to find x-intercept and y-intercept. For the x-intercept, we need to equal the equation by 0. So x-intercept is negative 5. For y-intercept, we must let x equal as 0. So we can find y as 5. So this is how the graph looks. As you can see, we are deleting the left side because based on the condition that given x must greater or equal than 0. So we don't need the left side or negative side. Since we are already sketched for the two equations, so now we just need to combine the both equations. So the graph will be like so what we need to do now is we need to find the domain and the range. If we want to find the domain, we must see the x line from left to right. So the domain is negative infinity to infinity. And for the range, we must see from the bottom to the top. As you can see, there is a negative infinity go to 0. And if you can see, 0 is an open bracket and 5 is closed bracket. And between the two numbers, there is no curve. So we need to find, so we need use the union for the question. And we must further the 5 to infinity. So the domain and range goes like domain negative infinity to infinity and y range negative infinity to 0 and union close bracket 5 to infinity. So this is the answer for the question. Thank you.
Thus, we're going to move on to question 2. Question 2 says that given that fx equals to 2x plus 3 and gx is equal to negative x squared plus 5, find g of fx. So first we're going to change it into a different form, and then we get negative 2x plus 3 squared plus 5 because we substitute x into fx because fx is the inside function. So we're going to expand and then we get the final answer. So the final answer is g of fx is equals to negative 4x squared minus 12x minus 4. Okay, so we're gonna move on to the last question, which is question 3. Given that fx is equals to 5x plus 4 and gx is equals to x minus 3, evaluate f of g6. First thing first, we're gonna find f of gx. F of gx is equals to 5x minus 3 plus 4 because x, we substitute it into gx. So we're going to expand and we get 5x minus 11. So next we are going to substitute x into 6 because we are going to find f of g6. So 5 times 6 minus 11, and then we get the final answer, which is 19. So we can conclude that f of g6 is equals to 19. Okay, that's all. Thank you and have a nice day.